In question 3, we're finding out, in 3 and 4, we're finding out whether the formulas are consistent. So I've got 3 formulas over here, and I'm going to do a tree, and I'm not going to negate any of the formulas because we're trying to find out if these can all be true together. So yeah, I'm going to leave them as they are, and if we find an open branch, then they can all be true together, but if all the branches close, well then they can't all be true together. I'm setting up the tree. And right, what shall I decompose first? Well, let's deal with this one, since it's best to leave universals until later, unless we have a clear plan for them. So line 4 comes for all x, negation of RAX. And that comes from line 3 using negation of existential rule. And I've decomposed that now. Now I have, I only have universals, so I'm going to have to apply them, and the variable I have is a. So let's do line 4 first because it's a bit of a smaller one. So for all x, this is true. That's the same as when I apply a. So not RAA. So I've replaced all instances of x with a. And I've now applied this to the variable a, and I got line 5 from line 4 using for all the variable a. Does this help me? Well, we don't know yet. I'm going to have to decompose formula 1. So for all x and y, Rxy implies fx. So I'll apply a to that one. That, remember, only applies to one quantifier at a time. So let's go for all y, ray, because I'm replacing all the x's by a's. Ray implies fa. And I've now applied this to the variable a, and that is where I get line 6. It is from line 1, applying the universal to a. And I've got another universal here, and the tree won't be complete until I've decomposed all of the universals. So I'll do that again with the only variable I have, which is a. So I've got RA, and replacing y's for a's. I'll put a implies FA. Alright, and I get line 7 from line 6, applying the universal to a. So now I've got an arrow, and I can decompose that. So negation of RAA and FA over here. So line 8 comes from line 7 using the arrow rule, and I can tick that off. And I forgot to tick off that I'd applied line 6 with the variable a. So, do I have any contradictions? I'm looking up the rows here. I've got of the formulas that I have left that I haven't decomposed are these 3 rows. So on the left-hand branch, I've got RA, negation of RAA, same as up here, and FA. So that looks like an open branch to me. There's no contradictions within that branch, but we need an open complete branch. Now, is this branch complete? So everything is ticked off, and all of the universals have been applied to the variable a, as you can see, like this. And the rule for a branch to be complete is that all of the formulas have to be ticked off, and all of the universal formulas have to be applied to all of the variables that appear in the tree. So if we had maybe a b or something appearing in some of the other formulas, sorry, not in the tree, in the branch. If we had a b appearing somewhere else in this left-hand branch, then that would, then we wouldn't have fully decomposed some of these universals. But the only variable we have, the only name we have is a, and they have all been applied to A. So yes, this branch is both open and it is complete. So that's what we were looking for. We found it, we found one open branch, and so that means yes, this formula is consistent, or these three formulas are consistent. Let's actually provide that counterexample that we found. Provide that model that we found. Sorry, not a counterexample. The model that we found where which shows how these formulas are consistent. So what we've got is a model, just reading it off of the branch really, we've got a model that has just one thing in the domain. The domain would just be A, and there is a relation if x and A, the value of that is given in line 2, it's going to be 1, and we've also got the relation rxy, and we've got A and A, so those are the only, we don't have V or anything, so is rxy that is raa true or false? Well, we can see here, for example, or over here that it's false. So let's check if those original formulas are consistent. So we'll use the partial truth tables method. So we've got x and y are the possible variables. Let's write out the formulas. We've got fa. We've got there does not exist x, rax, and the first one, I did these out of order. We've got for all x, for all y, rxy applies fx. So the different possibilities for x and y, the only possible combination is a and a. So the value of fa we can read from here as 1. The value of rax, well, we see what is x. X is a in this row, the only row we have to deal with. So we want to find out what raa is. That is 0. So does there exist an x, rax? We have to look only at the one row, and the value of that is 0, so the value of its negation is 1. So far so good. We've got two of the formulas have a value of 1. What about over here? Fx, well, x is a, so fa is 1. Rxy, well, x is a and y is a, so raa is 0. So we have 0, arrow 1, and that is that gives the value 1. So for all y, we have to check. We have the value 1, and for all x, we have the value 1. It looks a bit different when we only have one element in the domain. The large trees that you were doing last week with grouping the different combination of variables. Well, the only combination of variables when we only have a is just a or a and a, just everything being a. So it's a bit simpler. So the value of this formula is also 1. So we've just proven using this partial truth table that this model that we gave is a model in which all of these formulas are true. So that means that these formulas are consistent.